Okay, we've seen the product rule, so now let's have a look at the quotient rule. Now the word quotient basically just means a fraction, a divisor, something being divided. So previously we've seen what happens when you have a function within a function, which is the chain rule, a function multiplied by another function, which is the product rule. Now we're going to have a look at what happens when you have a function divided by another function. So f of x, not prime, getting ahead of myself there, f of x divided by g of x. Okay, what do we do here? Well, it's a bit of a longer looking equation, so I'm going to write it out and then I'm going to explain how to memorize it if you don't have it kind of to hand. So it's going to end up being a fraction, and on the bottom of this fraction is going to be g of x, so this denominator here, squared. Then on the top, we're going to have g of x times by f prime of x, so the derivative of f, minus f of x times by g prime of x. So the top here kind of looks like the product rule. In fact, it is the product rule just with a minus in the middle. And then the whole thing is going to be divided by this square, the square of this function here. So how do I remember this? Because it's not good enough just to remember that this is the product rule but with a minus, because that minus means this order matters. With the product rule, it doesn't matter which order we do it. We can do f prime x times gx plus the other way around, or we can do it vice versa. But with the quotient rule, we need to make sure it is g of x, this denominator, times by f prime of x first. So the, in a cringe way that I have of remembering it, is that g of x is on the bottom, right? He's on the bottom here, which means he has to go on the bottom again. But as a reward for having to be on the bottom twice, he gets to go first. Bear with me, right? I don't like it either. But he's on the bottom here, so he has to go on the bottom again. And as a reward, he gets to go first. Not his derivative goes last. He gets to go first. Make of that what you will. Laugh at it or use it, I don't really mind. So, this is the general formula. So now let's have a look at an example. In fact, let's have a look at this example. Sin x divided by cos x. I wonder if any of you just went, I see what's going on here. Sin x divided by cos x. Hopefully, if you're trigonometrically inclined, you'll realise that this is equal to tan x. So I'm basically about to prove the derivative of tan using my nice formula here. So let's see what we get. Well, first of all, I always like to make a little note up in the corner of what my derivatives are. So my f of x, and I'll label that here, is sin x. My g of x is cos x. So what's f prime of x? Well, no fancy chain rule, nothing weird going on. It's just sine turning into cos. And then for g prime of x, it is, again, nothing fancy, no chain rule. It is just cos turning into negative sine. There we go. So keep those in the back of our head, and now let's fill out this equation and see what we can do with it. So again, I've got gx, which is cos, we use blue, times by f prime of x. Well, f prime of x is cos x, so that's going to be cos x times cos x, minus f of x, which is sin x, times by g prime of x, which is minus sin x. I'm going to combine that minus and this minus. Sine, done. So just that minus sign there, I just combined with that minus there, okay? All divided by g squared of x, which is just the bottom function here squared, so cos squared x. Well, I can simplify this very nicely. If you're not very trigonometrically inclined, now's the time to be so, because on the top, hopefully we've got alarm bells ringing already as soon as it was written out. I've got cos times cos, which is cos squared. I've got a sine times a sine, which is sine squared, and I'm adding those together. Sine squared plus cos squared is 1. So I have 1 divided by cos squared x, or sec squared x. And using this nice quotient rule, I have proven the derivative of tan. Very nice. Right, let's have a look at one more example that doesn't include any functions that we're already happy with. So yeah, we'll have e to the 3x squared over sine of 3x, and let's speed through this. I'm gonna kind of call the equation from memory up in my corner here, always good to do. So I know my derivative is going to be, well, as I said, always remember the bottom guy sits on the bottom squared. He gets to go first up top. Ooh, x, g prime of x. I ran out of room there, but get the gist. And now let's apply this. So first things first, let's differentiate the top. So f prime of x. Well, again, chain rule. Hopefully you're very happy with this by now. Derivative of this bit here is 6x multiplied by the original, because it's e to the 3x squared. And then g prime x, sine of 3x, sine differentiates to cos. The differential of the interior is 3. Slap those together. We get 3 cos 3x. Now let's throw this all together into our formula. On the bottom, I'm going to have sine squared of 3x, and on the top, I'm going to have gx, so sine of 3x times f prime of x, which is 6x e to the 3x squared. All this does not look very nice. Minus f of x, which is this, e to the 3x squared, times by g prime of x, which is 3 cos 3x. I've run out of room. And again, maybe there's some simplifications you can do here. Can I see any? Apart from, factoring out an e, I don't think I can see any trig simplifications here. If you can, let me know. I may just be being stupid, but off the top of my head, can't see any of the 3x's. So we are done.